Hi guys, so this is 5.6, the cosine law. All right. So I will go through the get started part and I will leave the construct understanding for you to go over. Okay. In the get started part, it says there's a triangle ABC like this. ABC. Then this is little c, this is little a, this is little b, and you are to come up with two expressions for side b. Okay. Oh, by the way, this is a right angle. Now, in this case, since it's a right triangle, you can use the Pythagoras, right? Wherein the hypotenuse is b. So instead of writing c squared equals a squared plus b squared, it will be b squared equals a squared plus c squared. It's really the same thing. You just flipped around the different letters, all right? Or if you want, you can use the sine law to put this b over sine b equals a over sine a, or c over sine c. Really the same thing, okay? So there is your page 488. Okay, wait, page 408. Okay, so I would like you to read pages 488, the lower part, and 489 to take a look at how this cosine law is derived. All right, so the cosine law, I'm going to write it here. The cosine law is another way of coming up with the different values for the angles and the sides, and it depends on what is given. For example, with the sine law, as long as you can create a ratio between the sides and the angles, then you're okay. Now, what if you don't have the sides, or you can create a ratio between the sides and the angles? The cosine law will help you out. Like if it's giving you only the sides, then this is the one you're going to use. Okay, but the cosine law. This is found on page 489, the lower part. In any triangle ABC, c squared, which is a side, is equal to a squared plus b squared minus 2ab. Oops, sorry. Minus 2ab cosine c. Now, what does this mean? So, what it's saying is this, okay? So, if you have a triangle like this, right? ABC. If you're trying to find c, which is this one, so what you're going to do is you're going to find the value of a, square it, going to find the value of b, square it, add them together. Then you're going to subtract 2 times the value of a times b and the cosine of angle c. All right? So this is what you're going to use if the question usually would be giving you these three things, which I will highlight. Okay. You will use the cosine law if you are trying to find an angle, all right? And only the three sides are given. So what does that mean? You can't really use the sine law because you don't, or you're unable to create a ratio, all right? So if the triangle only gives you the three different sides, A, B, and C, and you are asked for one angle, any of those three angles, this is the one you're going to be using cosine law. All right, what else? If you are being asked for another side, all right, um, of a triangle, and then you are given two sides, okay, and then the angle between them, or what people say as the included angle, this is going to be used, the cosine law. All right. Now, if you're thinking, can I use the sine law here? No. You know why? Because for you to use the cosine law, there's a pair of there's a pair wherein a side would be paired with an angle and the side would be paired with the angle opposite that angle. So for you to be able to use angle C here, the side C should be given, which is not the case. Okay. So that's all it is. Now, I'm going to write something here, which is another way of writing the cosine law, which I don't think was given in this book, but it doesn't matter. All right. So this first one that I gave you, c squared equals a squared plus b squared minus 2ab cosine c, is what you use to find a side. Now, suppose it's an angle that you're using, or it's an angle that you're looking for. So suppose it's angle C that you're looking for. So what you need to do, or angle A for that matter. All right. This is just a manipulation of that earlier formula that I wrote. It's really the same thing. B squared plus C squared minus A squared over 2BC. So if you rearrange the first one, you will come up with this. Well, if you're thinking, why do we have to do that? Because in the first one, you will be able to get a side. All right. In the second one, you will be able to get an angle. That's why. All right. Okay. So let's take a look. I am doing um, check your understanding, page 490, number 1A. All right. Okay. Okay. So what does it say? In each triangle, determine the length of QR to the nearest tenth of a centimeter. So I'll just create um, a quick picture here. It's not really the nicest one. Okay. I'm just copying the numbers given. As you can see in here, there are two sides that are given, and then this angle that is the included angle, which means it's what's between those two sides. What are we looking for? In this one, we are to find the length of QR. Okay. Now, to find the length of QR, you are going to be using the cosine law. Why? Because QR is this one. Okay. And that is opposite angle P. But to be able to do that, we're going to be using the cosine law, which requires um, the sides being labeled using the small letters, right? So our QR would be side P. This is side Q. This is side R. All right. So really, QR is side P. All right. So how does our cosine law look like? It's going to be P squared plus Q squared plus R squared. Okay. Minus 2 QR cosine P. Okay. That P is an angle. So P squared equals, let's plug in the values if you're getting confused with what I just wrote so that you see. 10 squared plus 17 squared minus 2 times what is Q? 10. What is R? 17 times cosine of what is P? Take a look. 31 degrees. P squared is equal to 100 plus 289 minus 2 times 10, 20 times 17, 340 cosine 31 degrees. All right. Now, this is where the problem would be. You need to be very careful here. All right. Now, let me just get my calculator, 1.8774. Right. If you just do this all throughout using a calculator, sometimes you will mess it up. What do I mean by that? This is what I want you to do. So do everything like this, simplify. Now, please do not subtract 340 from 389. You don't do that. What you need to do is you will get cosine 31 degrees and then you will multiply it by 340. All right. 31 cosine times 340. All right. That would be about okay, uh 291.4368 whatever. Okay. Now you can subtract that from 389. It's about 97.56 or whatever. P is equal to the square root of this, which means about 9.87 or about 9.9. So what I want to caution you on here is this part here, because this is where the problem is always going to be. This. What I see kids doing is they will subtract the 340 from 389, forgetting that you have to do this first. Whatever that number is, you will subtract it from the first expression. That is the most common problem. Okay? So that's what is this? Okay. So that's CYU number 1A. I will leave number 1B for you to do. Okay. Next. Page 491. CYU number 2A. Okay. So in this case, it doesn't give you a picture. It just tells you in triangle KMN. KM is 16, KN is 11, and MN is 6. We are looking for an angle. All right, so we are looking for an angle. Since we're looking for an angle, this is the one that I'm going to use. Now, what does this mean? Um, what I would rather that you guys do is to create a picture, right? Okay. Now, it doesn't hurt to create a picture. So what I'm going to do is I will make a picture. Just so that I know the different sides and different angles. So let's say this is it. KMN. Okay. Now it says here KM is 16, so this is 16. MN is 6, so this is 6. KN is 11. Now this is not the scale. You might say that, how come 11 is longer than 16? It doesn't matter. Okay, that's not that. Okay. So let's plug in the different values here. Oh my God, my eyes are straining again. That's why you see me always um, scratch my eyes. Something's happening to my eye recently. So this is little m. This is little m. Okay. Now, what are we looking for? We're looking for angle m. Now, if we're looking for angle m, so that means if I should choose my different letters to represent this, so this one could be my um, angle A, my m, in which case side A would be little m. Are you with me? So let's continue. Cosine of m is equal to 6 squared, which is my b squared, plus 16 squared, which is my c squared, minus, let's see what I have. Looking at my work so that I don't have to redo it again. All right. Mm. Okay, right. Minus 11 squared over 2 times 6 times 16. Okay. This is 171 over 192. Now that remember that is cosine m. Therefore, to find m, that would be equal to cosine inverse of this, which gives you I don't know what is happening. How come it's doing that? It's about 27 degrees. There you go. Okay. So that 27 degrees would be um, now I will leave number 2b for you to do in the check your understanding. Right. I will do check your understanding number 3, page 492. Now, the word problem isn't really well, um, uh, what am I supposed to say? Well said, I guess, because I myself got confused. Anyway, a retaining wall is leaning at an angle of 70 degrees to the horizontal. A rigid support is to be placed 5 meters from the base of the wall, and it will be attached to the wall 2.5 meters from the base. Determine the length of the support to the nearest tenth of a meter, and the measure of the angle between the support and the wall to the nearest degree. All right, so this is how it works. Okay, so it is leaning at an angle of 70 degrees to the horizontal. So you have a retaining wall. All right. A retaining wall is usually it's for water. It retains the water. So I don't know if you understand it. That's why I don't really like the question. Anyway, it's the wall. This angle is about 70 degrees. So it's making a 70 degrees to the horizontal. There is a support that is to be placed 5 meters from the base of the wall. So there's a support here, right here. This one here is 5 meters. Okay. Now, it will be attached to the wall 2.5 meters from the base. So this is the support like this. Or support. Now, this one here, I need to erase something here. Um, so that we already know anyway which one is the wall. This one is 2.5. Okay. So what is the length of the support? So the length of the support is what we're looking for. All right. So, okay. So I'm going to create another picture for this time making it really, really simple. This 70, 2.5, this is fine. Therefore, we're looking for this side. Let's call it side A. All right. To find side A, that would be A squared equals B squared plus C squared minus 2BC cosine A. Now, which one is C? So this is side B. All right, this is side C. Okay. Let's plug in the values. A squared equals 5 squared plus 2.5 squared minus 5 times 2.5. Oh, minus 2 times 5, 2.5 cosine 70. If you're doing this right, it would give you about 4 point, no, a squared already, okay. Or a would be about 4.7643, which would be about 4.8. Okay, now that is the length of the support. Now you're also being asked to find the measure of the angle between the support and the wall to the nearest degree. Now that part is where it's not very nice because I myself was wondering which one is it that they're looking for. Well, apparently it turns out that this is the angle that they want. All right, where the support is connected to the retaining wall, and to be able to do that, we can already use the sine law, right? Because you have side A to be able to do that. Mm, so that means we're looking for angle C, right? Angle C because it's opposite side C. That'll be 5 over sine C equals A over sine A. Now I would expect that you're able to do this because this is just the sine law, wherein the angle is about 80 degrees. I'm just going by the answer now in the book. I also did it earlier and I think I came up with the same answer. Okay. So I think that's it for me today. I will post the homework along with this. I will not do example 4 or the check your understanding. I don't like the questions wherein it has a bearing of blah, 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 because we are not going to be dealing with that. The homework, though, I will be giving would have word problems as well. Okay. And in the homework that we will have for this section, those questions that would have questions about bearing, I will skip. Okay. That's it for me, people. Again, thank you for watching.